Now let's take a look at a product demo. Take a finance department in an Enterprise California, USA company. They've decided to migrate a few applications onto AWS. A dedicated VPC, 2 availability zones with public and private subnets in each, located in the US West region. We will need to provision Docker containers on AWS EKS in addition to functions on AWS Lambda to obtain a serverless model for the microservices. MySQL, Aurora database, and S3 are the data stores. The application is exposed to the internet via a load balancer protected by a web application firewall. Now that we've gone through the desired architecture, let's get to work. We start by logging in to create the network infrastructure. That includes the VPC, availability zones, and subnets. Behind the scenes, the bot will auto-generate the required AWS configuration and complete the setup. We then move to deploy the application infrastructure. The application is called Invoice, and we start by creating a logical workspace or tenant by that name in the finance network that we just created. Next, we can switch to the Invoice application. Here, we are going to create a virtual machine. Notice that the user provides a high-level specification only. Behind the scenes, the bot will generate the security group, IAM role, instance profile, and other AWS configurations. We are now creating an S3 bucket. The bot will auto-generate the IAM access policy for the host to access the S3 bucket. We can then move on to create a SQL database. The bot understands that in this case, it needs to generate security group-based policies against as an IAM. It will also set up backups, encryption, and other best practices behind the scenes. With network and network infrastructure in place, we next move to deploy first the Docker-based microservice. Here again, the user provides an application-centric specification while the bot auto-generates Kubernetes and AWS configurations that includes the deployment or stateful sets, node ports, ingress controls, and other such infrastructure details. The right set of access policies, security groups, ACLs are applied. It is important to note that the bot is performing all these actions with no presumptions about the application topology that it is being asked to deploy.
Many other diagnostic functions are built into the platform. For example, a quick view of the container logs. Or here, we're getting into the shell of the running container itself.
Now, let's deploy the Lambda function. We first upload the Lambda package to an S3 bucket. Notice that the platform implicitly provides just-in-time access for users for AWS console access with the right permission set. There are no access permissions to manage manually. After uploading the package, we specify the Lambda function parameters and the bot will do the rest. With all of the infrastructure in place and the application has been deployed, we can now do a sanity test. Good news, our application works.
Let's look at the other necessary tasks the bots performed for the infrastructure. Here we have the metrics dashboard set up for the Invoice application.
There are billing dashboards that organize your spend across the various cloud services and applications.
Next, businesses in highly regulated industries need a security and incident management platform, and guess what? That comes built in. All configuration changes in the cloud infrastructure are detected and controls applied. Compliance dashboards are readily available for auditors. Notice that all of this is set up without the user having to lift a finger. There's an audit trail of all actions in an application-specific context. Here, we are showing the audit trail of the Invoice application. Finally, there is CI/CD for daily code releases. DevSecOps are the future of cloud automation. To learn more, visit DuploCloud.com.